Welcome, friends of robotics. I'm Driansu. I want to do engineering for specializing in robotics, and because of that, this has been my end of baccalaureate project. My knowledge was very basic, and my electrical engineering teacher told me if I knew what I was getting into. When I first started this project and looked for information, I didn't find in YouTube any robotic arms moved by sensors, and because of this, I've decided to upload this video, just in case somebody wants to do something similar. This arm has 6 servos, it's programmed in Arduino, and has 3 different functions that will activate with 3 different sensors. Those are the movement, light, and sound sensors. The motherboard I use is the Arduino Leonardo and an expansion board, the PCA9685. For this project, I use the expansion board so I can connect the 6 servos the ARM uses, because the Leonardo doesn't provide enough energy nor have enough pins for connecting all 6 servos. The sensors are connected directly to a Leonardo because they can't be connected to this expansion board. Remember that depending on the sensor, it will be connected in the digital or analog pin. I installed some LEDs so the ARM looks a bit more colorful, and they're also connected to a Leonardo. The expansion board is connected to a power supply from a computer. It provides 5 volts. The minimum intensity you can use so the ARM can move is 3 amps. The servos are MG996R. During the time I've worked on this project, I had many problems, and I had to think solutions to solve them. First of all, I had to think the place of the sensors so they could detect light or movement, but I didn't want them to be too exposed. I decided to elevate the anchoring base and put the sensors under it. After putting the sensors under the anchoring base, their reception field was a lot bigger than expected, so I decided to put the light sensor inside a black tube. So the problem that the ambient light reflects on the tube is solved. I also put the sound sensor in another tube so it canalizes the sound produced into the sensor and the majority of ambient sound is rejected. The problem I had with the movement sensor was the detection range, even if adjusted at its minimum. To attenuate it, I changed the Fresnel lens the sensor had and put a little cone with a final opening space of 8 mm, so the sensor activates only if you pass very near it. The sensors are introduced inside a tube and held by a piece of rubber foam so they can be extracted easily. These tubes are fixed with a removable mastic. As an extra problem, the sound and movement sensors are adjustable for controlling how many sensibility they have to activate, so I had to find a solution for adjusting them in an easy way. I resolved that with a platform that had the exact measure so it could fit below the anchoring base, and then I did a hole in its back zone, pulling a barrette so it couldn't move. Whenever I want to adjust the sensors, I only have to remove the barrette and extract the platform that has the sensors. For the first function that will work with the movement sensor, I'll do this. First, I'll take these 3 cubes and drop them in the central zone of the platform. When the movement sensor sees these cubes, it will take this item and sweep them out of the central zone of the platform. After doing this, it will return this item to its place and the arm will go to its original position. This function will activate with the light sensor, with this lantern. When the light sensor receives the light emitted by this lantern, it will move to take this item in front of it, rotate it, and then drop it. After this, the arm will return to its original position. This last function will be activated by a sound sensor. Basically, if the sound sensor detects a sound that it's very loud, as an applause for example, it will move to a vertical position and answer to this applause. I hope this helps you, and greetings.